Alright, so now we're going to actually start with no picture this time. We have to do all of it ourselves. So our function is y equals x cubed plus 3. I like to first change this function to a y equals. So we know our a is 1 and our b is 4, hopefully, but we need a picture in order to do that. So what we're going to do is take our calculator and make this picture. So first you start with y equals, and you plug in the function. And we go to our window, and you put in 1 and 4, because that's what we have for our interval. And then you want to use zoom fit. But what zoom fit does is it starts and it finds the smallest y value to the largest. Well, that's not what we want. We want to make sure that we always have our x-axis showing, because we want that area all the way to the x-axis. So we're going to plug in 0 instead, and then now hit graph. And that is what we need to draw that picture. Like that. So that's 1, and that's 4. Now all we have to do is draw our rectangle like before, and make sure that our rectangle translates through the entire function like this. So no matter where I place the rectangle as it goes through, it is always between the function itself and the x-axis. So it is the same measurements, not same measurements, but the same two functions all through the entire thing. So that way when we rotate it, it makes our perfect disk. And so I can scroll out to look at this. So there is our disk. You can even see it on the outside. And so then now, as it rotates through the whole thing, all we have to do is find the area of that one disk, and then take the integral and add all of them up. And so that rectangle is just our radius. See how it's creating it? You can see it here. That rectangle is the radius of our function. So now we're going to draw our quick little picture. We're going to first rotate this in a nice circular fashion, because it says we're rotating it about the x-axis. So that is our rotation here, that we're moving it about that axis. And I like to always take the beginning as well, and the end. And then that way you can draw the solid that goes with it. So then we take our one disk, we label it with our radius, and our radius here is the y function, and dx, just like we've been using before. So it tells us what we need to use. So our radius is the y function. In this case, it's x cubed plus 1, because that is our y. So our radius is our y, which is x cubed plus 1. That's this function right here. All right, so now that we have our radius, area of a circle is pi r squared. And then we just plug in our radius, which is x cubed plus 1. No need to do anything else after that. So now we take the integral from start to finish of our area dx. So what is the starting point that we have as we move our circle through this solid? It's going to start at 1 and then end at 4. So our rectangle is going to start at 1 and go all the way through to 4. So our first radius would be at 1, our last radius is at 4. So we're going from start of 1 to finish of 4 of our area, and now we can just plug it in. I like to put the pi outside because it's a constant. And now we just plug that in our calculator and we have an answer. So it'd be 2470.93 pi, which is already horrible, so we're just going to use that one. 7762.65. 65. And there is our area. All right, so let's try another one just so you can kind of get the idea that they're all the same. So again, we're going to plug this in our calculator from 0 to pi, zoom 0, and then put it back to 0. But sine of 0 is going to be perfect. So we plug it in, put our window of 0 and pi, and then zoom fit, that's 0. And it'll graph it perfectly for us. Now we don't have to worry about here because 0 and pi are both going to give us 0. So we're good. So you hit trace, second pi, and hit there. You'll see we're at 0 already. So we don't have to go back to the window, change our y-min to 0. It's perfect. So let's draw that picture. Good enough. And then we draw our rectangle. Remember, our rectangle here is our radius. So again, if we move this through our entire function, it is perfect. So here's our picture so we can get an idea what's going on. So again, that rectangle you can see moves perfectly. It's always the function to 0 all the way through. So that's the perfect rectangle. And then now we rotate it, and it makes this egg shape. But no matter what, you can still see our radius is that circle. And again, all we're doing is moving that circle through the entire thing to create our shape. So as it goes through the entire shape, entire function, transfers it through the function, all through the x values, from 0 to pi, it creates that solid. So now all we have to do is rotate it around the x-axis, like an S. So like this, and try to be proportional here. Try to get it a decent circle. That's close. Mine's pretty bad there. And so as this goes around, it would be the same thing from here to here. So it's just going to be a mirror image. Oops. Mirror image means it goes down like this through there, and it makes that football shape. That looks horrible, but good enough. So now we draw our circle, and again, this would be dx and y. You always want to label it. So our y here is the square root of sine x. So our area is pi r squared of that disk with a radius of the square root of sine x. So we plug that in, pi square root sine x squared. That cancels, giving us pi sine x. And so now we do the integral, and there's an absolute value around it as well because of that. But we're talking about positive values here from 0 to pi. So we can just use that pi sine x. And so now we have the integral from start to finish, which would be 0 to pi. And so that's going to give us all of our circles. So hopefully you can picture that circle again going through there from 0 to pi like this. It just fills it in from 0 to pi. So those x values that we plug in will give the areas and the volumes actually of each of these disks. And then we add them up with the integral. So our area, pi sine x, and then what's the thickness of the disk? Dx. So now we can add up all of those volumes using our calculator, which is 2. And now if we had other trig functions, you'd really want to do them by hand. If they need an exact answer, your calculator's not going to give us the exact answer unless you're pretty good at figuring out what the exact answer is from the decimal. And so this would be 2 pi. That's our area. 2 pi. And so this is the disk method.